So let's talk about measurement. Measurement is foundational in all of science. Without measurement, we cannot collect data, and without data, we cannot reach valuable conclusions that help drive everyday processes in chemistry, physics, all the sciences. And so, what I thought I'd do is walk you through a lab that I do with my students in class and kind of talk about the importance of measurement. And in particular, in this video, I'm going to be talking about two things. One is accuracy, two is precision. And the goal is to get the most accurate and precise measurement that we possibly can. Now, accuracy is defined as getting as close to the exact actual value that you possibly can. Now, what is that exact value? It depends on what you're measuring. And so I'll talk about that in the example I'm going to give you, but think of accuracy like, imagine a bullseye and you throw a dart and you hit exactly in the middle. That middle bullseye on that dartboard represents being 100% accurate. And the farther you get away from that bullseye, or the farther you get away from that accepted value, the less accurate your measurement actually is. The second term that I want to talk about is precision. And precision is about reproducing that measurement that you were able to get. So oftentimes in science, we do not just collect one data and call it, oh, data point, and call it, oh, that's good, because that's not very convincing. Instead, what's a lot more convincing is if we generate and gather that data more than one time. Usually it's done at least 3 times. And then to represent that value, they take an average of those values. Now, if those values are not anywhere close to each other, that is called not precise. But if they're all close together, that is precision. And so on the dartboard, as long as if you throw 3 darts, as long as those 3 darts are clumped together, that's precise. But if it's not, if it's all over the place, then it is not precise at all, okay? So let's talk about a lab example. One lab that we do in my physics classes is that we do a simple Tumble Buggy Lab. And you see, you turn it on, and basically what you do is, in this lab, let me show you the board here real quick. I'll talk about the numbers in just a second, okay? But you start here on the start line right here, and then somebody has out a stopwatch, and every 1 second, what they do is they put a mark down. 1, 2, 3. So every second they put a mark down. And so as it goes, you have a trail of marks here. So let me just show you kind of what it would look like. Okay, I'm not actually going to mark because I've already collected the data, but you say ready, set, go. 1, 2, 3, 4, 5, so on and so forth, okay? And then you have these marks. And then what we do to generate precise, to make sure our numbers are precise, we would take that tumble buggy, turn it on again, and do the exact same thing. 1, 2, so on and so forth. And we do it a total of 3 times. That way we have 3 individual measurements for each second. So now let me show you the board that I've generated. This is the board. Let me explain what this means. The red ticks right here represent the first time that I did it. The black ones represent the second time that I did it, and then the purple represents the 3rd time that I did it. And so here's what we would be thinking about. Let's look at data values number 1 at 1 second. This would be like the darts on the dartboard here, okay? Now, do we know how accurate it is? At this point, no, we do not. We don't know how fast this tumble buggy is moving, and so we can't really speak to the accuracy of it. But the fact that those values are all close together, that indicates high level of precision on something that as simple as monitoring a tumble buggy moving across. So this is what would be called high precision. If I wanted even higher precision, all of these marks would be the exact same, okay? And I could get out my measurement, my meter stick, and measure how far that is from the start. Now, let's look at number 2. I'm just gonna circle these. These are at 2 seconds. These are at 3 seconds. These are at 4 seconds, and you're starting to see something kind of massive. In fact, this is at 5 seconds, and it's not even, you can't even see 5 on the screen. So what's happening here? Well, this one right here, something appears to be happening, but I can kind of speak to this a little bit. their precision. Each one of these I would say is not very precise in terms of 3 measurements. What I look at with this and this is these guys are somewhat, the red and the black first and second trial are fairly close together. Same with the 3rd trial, same with the 4th trial, and really same with the 5th trial too. What's really off is that 3rd trial. So my question would be, in this case, is each one of these has very low precision, but what's causing it to have low precision? It'd be this one right here. And so what we do is we say, okay, is that an outlier? If it's an outlier, we need to justify that it's an outlier, and the best way to justify that it's an outlier is to get this and run it one more time. And if you run it one more time and you notice that the tick is right here, then you know that that's an outlier and you can discard it. This is accuracy and precision. Mainly this right here speaks to precision in data collection. And in later videos, we talk about how to be exact in our precision and using our measurement tools.